A malware just infiltrated your network. This malware could be so destructive or not, and this evade your first layer of detection. Good thing is that the preceding layer was able to block it. The question here is, how could this program surpass the first layer of detection? A program is a set of instructions created by the developer to do the required tasks and functionalities. Each task and functionalities applies the concept of binary, either if it's good or bad. Either way, a program is set on what it is set to do. So if we are to dissect a program, this malicious program, then we can prevent our network for the next possible outbreak. This, ladies and gentlemen, has been one of my goals. That is to create a tool that would dissect this malware, analyze what they're capable of, without entering God mode. A quick overview of the malware file so you can easily tweak or modify your defensive system basing from the findings. This tool does not only analyze or reverse engineer a malware program, but it also executes same functionalities with any program. This is the first part of our product overview as for now. I'll show you extracting the PE section, PE imports, and some more file informations like file hashes and file creation and modified date. And with that, you already know what it is. Cue the intro. So here's our tool, MAKD. This is the Malware Analysis Kit Dissector. So there are two approaches on examining a malware file. We have static analysis and a dynamic analysis. Static analysis examines the malware without running it. Dynamic analysis, this involves running a malware to have in-depth analysis with more detailed results. This tool covers the static analysis with a nearing to dynamic analysis. That is because our tool will provide you the information and pierce through the inside of the malware itself. So for now, let's input and analyze the beta version of Spyder and see if this could be tagged in a category of being a malware. This is the beta version, and let's see what can our tool collect from this. Here's the result, and there it is. For now, at least in this version, it is divided into three sections. We have here the P section, P imports, and the file information. Some basic file information stuff. Let's have a review on this three sections one by one. So what is a PE? This is also known as the P file or the portable executable file. Portable executable file is used for Windows executables, object code, and DLLs. The PE file format is data structure that contains the information of the necessary for the Windows OS loader to manage the wrapped executable code. PE file begins with a header that includes information about the code, the type of application, required library functions, and space requirements. The information in the PE header is of great value to the malware analyst. PE executables, on the other hand, are divided into two sections. So we have the header in the section. Header contains information such as memory address, location, and the size of the code. And sections comprise the main content of the file that involves code, data, resources, and other executable files. So each section has its header and body. Let's dive into this one. The output of this program starts here in the PE section. This portion has been indicated by section name, the section's virtual address, the virtual size, and the raw size. So by looking at the section table, we can find an indication if a certain file is suspicious. If, for example, if the text section raw data size has a value of 0, while virtual size is greater than 0. Data size here is 40,448 bytes. By the way, the sizes here is in bytes. In the next version, I'll just convert it into megabytes. So by default, I set it to bytes. Okay, so right now it's 40,100 bytes for the virtual size and 4,448 for for the raw size. The raw size here is not 0, and the virtual size here is greater than 0. Yeah, I think somehow it is suspicious in nature because it has 4,100 bytes greater than 0. What can we see in the .text section? This contains the instruction executed by the CPU. And this is the section where the program's code and the unpacked files code can possibly seen in this section. Also, we have .data. In this section, it contains a program for the global data. All the global data variables in the program are stored in here. As you can see here, the virtual address is in this hex value here, and this is the sizes. And next, we have the BSS. This represents the uninitialized data for the application. This only indicates that the program is in Python because variables often are not initialized. Then we have the R data. This contains the import and export information. It can also store read-only data used by the program. So this only means that the program make use of a read-only file type of data, which contains 20,232 bytes for the virtual size, and the raw size is 20,480. iData, it holds the import directory. This uses executables and DLLs to designate the imported and exported function. And the CRT is the data reserved for the C runtime library. This means that the program make use of a C runtime library for execution. So in the TLS section, it provides a direct PE and COF. Lastly, the data resource or the .rsrc resource used by the executable that are not considered part of the executable, such as the icons, the image, menus, and strings. In the PE import, this is where you usually get the functionality of the executable or the program itself. DLLs and functions loaded would indicate the functionality used on the executables. So from the sample test run, we have kernel32.dll is utilized. This would mean that the DLL contains core functionality such as access and manipulation of memory file and hardware, as this reflect the PE function utilized. So this is the PE function for this DLL here. So with all that, I'll indicate some suspicious function, and since I am also the creator of this program, I'll explain its functionality with Spyder. So we have this create process W within this memory address here. Create process W, it creates a new process and its primary thread. The new process runs in the security context of the calling process. And yes, Spyder, as you know, indeed has a lot of process calls upon execution. And next we have this command line W here. This retrieves the command line string for the current process. I did integrate command line functions like CLS, exit, and some network command syntax to have a more hacker-like feel on the application. Get current process. This gets a new process component and associates it with currently active process. There are running processes as the program executes a method in Spyder, and one of which is the create new file process. It is running while crawling the website. Then we have the get module file name W. This retrieves the fully qualified path for the file that contains the specified module. A variable was set for this in order for the program to read and open the file input. Then next we have the load library A, or this two load libraries here. These are the runtime dependencies which resolved by the Windows PE loader upon image execution. And next we have this set environment variable W. Sets the contents of specified environment variable for the current process. In this case, the command input that is utilized to all the function on the program. Sleep, basically, this is when the sleep time function method was used, and the sleep function suspends execution of the current thread for a given number of seconds. So I set it up to 5 seconds for the exit greeting. This is where all the processes that are running in the program is terminated. When the process is done, I always make sure that the process is terminated. So once again, the kernel32.dll is a very common DLL that contains core functionality such as the access and manipulation of memory files hardware. So whenever this DLL is loaded, expect to have that kind of functionality. Msvcrt Dll. This is a module containing standard C library functions such as printf, memcopy, cos, etc. As you can see here, these are all libraries and the modules loaded by this DLL here. Seeing all these functions, what would this remind you of? Exactly, these are libraries for all the programming language. Knowing this concept, we can gather information and ideas the language structure of the application. So in this case, we now have the idea of what module and library are used on Spyder. WS2_32.dll. These are basically networking DLLs. A program that accesses either of this most likely connects to a network or perform network-related tasks. So specifically this function here that was loaded because the program does perform connection to web servers to perform some web crawling tasks. And lastly, we have the file information, which mainly composed of the file location, size in MB, and its equivalent file hashes. We did some programming with regards to extracting the file hashes. You can click on the top left side on this video. Here it's equivalent hash here, just MD5 and SHA-256. The file creation, in this case, it's Friday, March 6, 10:53 AM of 2020. This indicates that this is the time my file was copied to this machine. Though this program was created originally in 2017, file creation here also indicates that the file was transferred in this data. And the proof of that is the last modified, which is Monday of June 19, 2017, 8:53 AM. This indicates that the last time I made changes in this beta version of Spyder was... I think this would do for now. On the next video, I'll discuss the next feature on this tool. Stay tuned on that so you can see how this tool would ease up the static malware analysis and can help the malware analyst big time on dealing with this destructive program.